So in this question, we're told we have a charge density of 80 microcoulombs per meter cubed when R is between 8 millimeters and 10 millimeters and 0 otherwise. So we want to find the total charge inside the 10 millimeter surface. So this is going to be the integral from 0 to 2 pi with respect to phi, the integral from 0 to pi times sine theta with respect to theta, the integral from 8 millimeters to 10 millimeters, r squared, and then since rho is a constant, we can just take that out, dr. And I've separated the integral up because it's just a product of different things, and the limits don't depend on any of the other variables, and that means that we can decompose the integral in this way. So this is going to give us 2 pi. This is going to give us 2 because the integral of sine is minus cos, and minus cos of pi is 1, cos of 0 is minus 1, so this gives us 2. So we get 4 pi times rho. And then we've got this integral here. So we can divide by 3 because when we integrate this, we get a third r cubed. And then we get 10 cubed minus 8 cubed. But remember that these units of millimeters are also cubed, so that's going to be 10 to the minus 9. So this gives us a charge, 4 pi divided by 3 times the density, which is 80 times 10 to the minus 6, because it's microcoulombs, times 10 to the minus 9 times 10 cubed minus 8 cubed. And this is a charge of 1.635 times 10 to the minus 10 coulombs. So now we want to use Gauss's law to get the dr, the radial component of dr at r equals 10 millimeters. Well, this is going to be the charge divided by 4 pi times 10 millimeters squared. So let's divide our charge by 4 pi times 10 to the minus 2 squared. So that's 10 to the minus 4. So that gives us 1.30 times 10 to the minus 7 coulombs per meter squared. And we're also asked to find dr at r equals 20 millimeters. Well, since there's no more charge between 10 and 20 millimeters, we can just use the fact that it's proportional to 1 over r squared. So we're going to multiply, so this is going to be dr at r equals 10 millimeters times 10 squared over 20 squared. So that's a quarter of what we had before. And this gives us 3.25 times 10 to the minus 8 coulombs per meter squared.